Hi, it's 7 a.m. in morning in Noida, Delhi NCR, and it's freezing. Welcome back to Analysis Robotics. So I was watching this video made by Cleo Abraham,
Is a quantum computer.
and I was fascinated by how this tech is being applied in almost every industry in the world right now, and why all the companies are running behind to invest in this particular thing. So I did a little bit of research and I found out that why these companies are investing so much into quantum computing.
Large-scale quantum computers.
The IBM Quantum System 2.
So, wanna know more? Let's find out. What if I tell you that quantum computing can solve a problem which takes millions of years for a supercomputer? It sounds like science fiction, right? But that's true. And today we'll just break down quantum computing. Even if you are a tech enthusiast or just curious, we'll break down into why we are using quantum computing, what is quantum computing, and how is it working. Akasha. So let's understand what is quantum computing. So for that, we have to compare it with the classical computers. To do that, classical computers used the term called bits, which is 0 and 1. But in quantum computing, they use the term called qubits, both 0 and 1 getting at the same time. And that particular concept is called superposition, which means imagine flipping a coin, and while it's spinning, it is having both heads and tails at the same time. That particular concept is called superposition. Quantum computers harness the principle of quantum mechanics, which is mean by that it can break down everything into atom and electron level. And there are two topics for this thing. One is superposition and one is entanglement. Superposition means, as I said, it allows qubits to exist in multiple states simultaneously. By using that, it can find multiple probability outcomes at the same time, whereas a classical computer can only find one single probability outcome at a single time. To take an example, you are solving a maze with different probabilities at the same time, which helps you to solve it faster. It's like finding one key out of millions of keys in a single room. So let's talk about entanglement. Entanglement by means that when two qubits become linked together, the change in state of one qubit will affect the change in state of the second qubit. No matter how apart they are, one qubit can affect the outcome of the second qubit. So that's entanglement. So Albert Einstein called this particular concept spooky action at a distance. Entanglement helps quantum computers to solve problems more efficiently by linking together. For example, think of two twins and they know a secret language. Whenever they want to communicate, one person over here can talk something and the other person will understand. So no matter how far they are, they can talk to each other. So let's understand why quantum computing is so important. Quantum computing is important because it can be used in very different areas where classical computers struggle, such as cryptography. You can find new encryption methods which classical computers are using, but still it fails to encrypt. So you can use in cryptography, you can use in drug discovery, you can find out different molecules, you can mimic new molecules, you can study the previous molecules and create new molecules out of it. So you can use that in drug discovery. You can use it for optimizing different problems. For example, in logistics, you can optimize different logistic routes to improve your efficiency in logistics. And you can use in artificial intelligence to improve your algorithms to make it more faster, more short algorithms to make it quicker. So think of it like classical computers can solve every problem step by step. At the same time, quantum computers analyze every possibility and solve it instantaneously. To give you a more insightful example, what if we could find out the weather of a day after 2 weeks with pinpoint accuracy? And what if we could find out the cure for a disease just like a Google search? Of course, quantum computers comes with its own challenges. So the main challenge is like keeping and storing it in a particular space safely. And because these quantum computers are extremely sensitive to environment. Being affected by environment is a term called decoherence. Plus, quantum computers are not yet ready to take over the classical computers because they are still on the research stage. Instead, they'll just completely track particular areas where classical computers are lacking and they can solve just one particular area. The good news is that the companies like IBM, Google are already doing the research in the quantum computing area. It's highly likely and highly possible to bring a proper, amazing quantum computer in next upcoming decade. I am personally excited for that. So quantum computers might sound like a sci-fi fiction thing, but it's actually very helpful in future. It can do more faster and secure payments. It can do everything but almost 10 to 100 times faster than the classical computers. If you like to know more about quantum computing, you can use different sources. You can learn courses from edX or Udemy. You can do quantum computing programming toolkit by IBM Qiskit, and you can also learn multiple quantum computing related topics from YouTube, or you can explore these different topics. Other than that, there haven't been a particular dedicated syllabus or course yet for the quantum computing. So that's how you can access quantum computing at the moment. So basically, quantum computing is not about creating new computers. It's about thinking in a new way to solve the problems which we are facing right now. Who knows, you could be a part of the next big thing called quantum computing in the world. And I was really excited to make this particular video. And that's a wrap for the quantum computing technology for the time being. So see you in the next one.